All right, so we found out that pKa tells you how strong an acid is, and so we can use these pKa values to predict the major product in an acid-base reaction, right? When I combine two components, which one's going to be the acid? Which one's going to be the base? So let's take a look at an example of this. We'll have this compound right here. This is known as a carboxylic acid. We'll have some hydroxide reacting, and we want to predict, right, here's the products. We want to predict which side is favored, the left side or the right side. And so what we want to do is use our pKa chart. And remember, this pKa chart tells us the strength of the acid. So we have to identify which component is acting as the acid. The acid is the H plus donor. And so going from left to right, we can see that this guy is the acid. And so we can find its pKa. If we look in our chart, find this guy right here at 4.75, right? And then if you're thinking about this hydroxide is actually acting as the base, right? This is a pKa chart, not a pKb chart. So we want to find the pKa of the conjugate acid, right? Which in this case is water, right? It's this guy over here. And so in our chart, what we need to do is find water, and we can find it right here at 15.7, right? And now we have our two values. And then we need to ask ourselves, which one is the stronger acid? Well, it's the one with the lower pKa, or the carboxylic acid, right? So the carboxylic acid is the stronger acid. And so that's what will act as an acid. Right? It's the stronger acid, so it's going to act as an acid. And so we can show this in multiple ways. One way to show this is like so. What we do is we do this equilibrium arrow, but we make one arrow bigger than the other to reflect which side is favored. So we make this arrow pretty big and then this arrow pretty small, and that means that the right side is favored. Right? The products are favored here. Let's take a look at another example. Here we have acetone plus hydronium. Reacting to give this protonated acetone and water. And again, we want to use our pKa chart. And again, we want to be careful. We want to find the acid here, whichever component is acting as the acid, right? So if we're thinking about this side over here and looking at our products, which one's acting as the acid? Well, it's the H3O plus that's acting as an acid. And so that's the pKa that we need to find. And so that's at negative 1.74. And then we take a look at the product side of things, right? If we're going from right to left, which one of these components is acting as the acid, right? Well, it's this guy right here, the protonated acetone. That's what's acting as an acid. And so we need to find its pKa, and we find that right over here at negative 7.3. And then we ask ourselves, which one of these is the stronger acid? Well, it's the protonated acetone. Right. So the side that is going to be favored is the side with the protonated acetone acting as an acid, right? So in this case, the left side is going to be favored. Right, so if you mix these two components together in a beaker, most of what's in your beaker is the stuff on the left side, not so much the stuff on the right side.